Hi, today we're going to be talking about multiplying and dividing scientific notation. And so first of all, I'm going to be kind of showing you how to do it on your calculator, and then I'm going to kind of show you the why, so kind of without a calculator, and understanding how things are actually done. All right, here we have some examples of scientific notation, and we are multiplying scientific notation. Example number 1, we have 3 times 10 to the negative 5 times 5 times 10 to the negative 2. And what we want to go ahead and do is we want to look at these. First of all, what I'm going to have us do is actually look at how do we put it in our calculator, because we can do that. And we can go ahead and look at that kind of stuff. So see how it kind of matches. We do want to put parentheses around our scientific notation number, and then use the little caret sign, right? The little rooftop, to be able to go ahead and put it in. So 3 times 10 to the negative 5. And then here is the second part, or the second number. So we have, if you look at it, we have it as times parentheses. Again, we put parentheses around our scientific notation numbers. 5 times 10 to the negative 2. And we're going to go ahead and press enter. If we press enter, we have this number here. And if we are doing, once we went ahead and pressed enter on there, see how sorry, we need to go ahead and check on it, look at it, and see what's going on. Is this a scientific notation number? It is not. And if we start with a scientific notation number, we want to end with a scientific notation number. So what I'm going to do is I'm going to write that down. So we have 0, and then we have 1. So if we look at it, we have 1, 1, 2, 3, 4, 5 zeros. Okay. We're going to go ahead and write that down. So 1, 2, 3, 4, 5, and then a 1 and a 5. So we want to go ahead and make it so that the final answer is a good scientific notation number. I want the decimal place to be here, so we want to make it as 1.5 times 10, and then we need to figure out the exponent. So we're going to go ahead and move our exponent. So it's 1, 2, 3, 4, 5, 6 times. And the final answer is going to be a negative 6, because the answer is a decimal. And negative exponents in scientific notation, it makes it a decimal number. So kind of keep that in mind. So let's kind of understand the reason why. So let's get rid of our calculator stuff. And let's walk through the steps of understanding how to do this kind of why or by hand. So one, we want to combine the front numbers first. So we want to go 3 times 5. And we do 3 times 5, and we are going to go ahead and get 15. And then our second thing we want to go ahead and do is we want to combine the 10s together. So we have it as 10 to the negative 5 times 10 to the negative 2. And we want to go ahead and figure that out. And then kind of combine them together. So remember when we were combining exponents, so the 10s are being repeated over and over and over again. And with our exponents, we can kind of combine those together, or we can add them. So negative 5 plus a negative 2, that's going to give us a negative 7. So if we look at what we have left over, and so we have it as times 10 to the negative 7 here. So we have 15 times 10 to the negative 7 so far. So we've done this so far as the steps itself. We want to combine the steps together. We want to multiply the front numbers. We want to multiply the 10s together. And then we want to write it as a scientific notation number, which we have done. But then our last thing we want to do is we want to check and make sure if this is a good scientific notation number. So is this a good scientific notation number? This is 15 times 10 to the negative 5. The 15 is not a good scientific notation number. As you can see, kind of give you a hint. We're going to move that decimal place over. So it was a bigger number, we're making it smaller. So then up here, we're going to make it bigger, and we moved it over once. So we're going to make it bigger by 1. And then if we put all of that together, our final answer is 1.5 times 10 to the negative 6. If you see, we have 1.5 times 10 to the negative 6, 1.5 times 10 to the negative 6, we have done this correctly. So we've actually shown you how to go ahead and do it that way itself. So let's go ahead and let's look at example number 2. Example number 2 is we have 2.5 times 10 to the 8th times 2.3 times 2 times 10 to the 3rd. Again, we want to combine our front numbers together. So we have 2 times 10, 2.5 times 2. And then we want to put our 10s together. So we put our 10s together. We have 10 to the 8th times 10 to the 3rd. We want to go ahead and we want to multiply the 2.5 times 10. And so we're going to get 5. And then we want to combine our 10s together. So how many 10s do we have in the first group? 8. How many do we have in the second group? 3. Combine them together. How many do we have total? Where we're going to have 11. So again, we can put those in our calculator and kind of look at things that way. So here is my 2.5 times 10 to the 8th. Here is my 2 times 10 to the 3rd, and we're multiplying them together. Remember, that's multiplication in there. We're multiplying them together. And then what do we end up getting? Well, we end up getting the 5 times 10 to the 11th. So let's look at that. This is a little bit different. See how we have the 5. In fact, I'm going to make that a little bit bigger so we can really kind of look at that. So we have 5, and then it says times 10 to the 11th as the final answer. Some of them, again, we'll put 5e11. That is the same thing as scientific notation. So it's 5e11, so it's 5 times 10 to the 11th. And this, because the number is actually really big, the calculator can't do the big numbers, and so it just kind of puts it back into scientific notation. And so you can actually put it in there. We don't have to move anything around. We get that actual answer itself. So again, we can do it by hand, or we can go ahead and do it with our calculator, but at least we are understanding why. Let's go ahead and look at example number 3. So we have 2 times 10 to the negative 4 times 3 times 10 to the negative 4. So let's go through the steps again. We're going to go ahead and we're going to combine our front numbers. So we're going to do 2 times 3. We're going to combine our 10. So we have 10 to the negative 4 times 10 to the negative 4. And then what do we end up getting? Well, 2 times 3 is 6. And then we have 10 to the negative 4, 10 to the negative 4. Combine those together, we have 10 to the negative 8. And we can go ahead and look at it as far as our calculator. So here is the 2 times 10 to the negative 4. Here is the 3 times 10 to the negative 4. Here is our, well, whoopsie daisy. It actually didn't go ahead and put it into scientific notation. But we can go ahead and look at that. We can have it as, so we have how many decimal places that are there. As far as zeros, there's 1, 2, 3, 4, 5, 6, 7. There's 7 decimal places, but we got to move it to the 8 over here. That's what makes it as far as the negative 8. Because again, it's negative because it's a decimal. And we have to move it from here all the way over here to make it a 6. Not 0.6, but 6 times 10 to the negative 8. So again, we need to understand what the numbers mean in calculator-wise, and then we also need to understand as far as the full reason why. Let's go ahead and look at the next example. We have 5 times 10 to the negative 4 times 5.4 times 10 to the negative 9. Again, let's go walk through the steps. We combine the front numbers together. So we have 5 times 5.4. We're going to combine our 10s together. We have 10 to the negative 4, 10 times 10 to the negative 9. Let's combine those together and go ahead and do it. 5 times 5.4 is 27. Okay. So then also, if we look at it, we now have the exponents put together. And if we look at those kind of things, we can actually see that we have 10 times 10 negative 13. The reason why we have the 10 times negative 13 as the exponent there is because of the 10 times negative 4 plus 10 times negative 4. Negative 9 is actually what that should be. And if we add those together, we get the negative 13. But if we look at it, is this a good scientific notation number? This is not. This is 27. That is a number higher than 10, so that front number for our scientific notation cannot be higher than 10. So we have to go ahead and move the decimal, as you can kind of see here. So we're making this smaller. So then that means we have to go ahead and make the top part bigger, and we're doing it add by 1 because we only moved 1 decimal place. And then if we go ahead and put all of that together, our final answer will be 2.7 times 10 to the negative 12. And so again, if we want to go ahead and look at it when we go ahead and put it into our calculator, we have the 5 times 10 to the negative 4. Again, there's parentheses around it. And then we are putting in multiply by 5.4 times 10 to the negative 9, because that's what it should be. We press enter into it, and if we look at it, we have 2.7 times 10 to the 12th. Again, this is how our calculators will, well, at least this one, 2.7 times 10 to the negative 12, or 2.7 E, or E, and then negative 12. That also shows the same answer for all of it. So we end up having those ones there. Moving on to our last example. We have 7 times 10 to the second, multiply by 3 times 10 to the fifth. And if we walk through the how to do it by hand, we're going to go ahead and take the front numbers. We're going to combine them together. So we're going to have 7 times 3. Then we're going to take our tens or our exponentials of those that are being repeated over and over again. We're going to combine those together also. So we have 10 to the second times 10 to the fifth. And then we're going to go ahead and do 7 times 3. 7 times 3 is 21. And then we're going to go ahead and do 10 to the second times 10 to the fifth. Again, we are going to go ahead and combine those together. So we're adding those exponents. We're going to have 10 to the seventh. But if we look at the front number, this front number is 21. 21 is not a good scientific notation number. We have to go ahead and change it. So as we can kind of see just a little bit, we're going to go ahead and move our decimal place over 1 to make it 2.1. And because down here we're taking it from a bigger number, making it smaller. Then on the top we have to make it bigger, and we moved it by 1 decimal place. So we're going to go ahead and add 1. And then our final answer on here would be 2.1 times 10 to the 8th. Again, we can go ahead and take it. We can go ahead and put it into our calculators. So we have it as 7 times 10 to the second times, so notice how there's a multiplication in there. 3 times 10 to the fifth. We press enter. And if we go ahead and press enter, we get this really big, huge number itself. And we have it, it's there. So we need to go ahead and write that down, and then we need to put it into scientific notation. So we can go ahead and write it down. We have 21, and then how many, so we need to figure out how many zeros after we have those 21. Let's go ahead and let's count how many. So there are 1, 2, 3, 4, 5, 6, 7 zeros at the end. Let's write that down. So we're going to have 1, 2, 3, 4, 5, 6, 7. Our decimal place is at the end. We want to make it a scientific notation number, so it has to be 2.1 because the front number has to be a number between 1 and 9.999, right? So let's go ahead and let's move that decimal, and let's move it over. So we have 1, 2, 3, 4, 5, 6, 7, 8. So now we have times 10, and then we have to figure out, is the 8 positive or negative? It's a positive 8 because the number that we had was a number that was bigger than 10. And so those are positive exponents themselves. So again, we kind of showed, hey, here's the way of doing it without a calculator. Here's a way of doing it with a calculator itself.